Hey, how's it going, people? This is I'm gonna redo the video for the last EIGRP path selection that I did, solely because of the fact that I didn't have this written up before. But I got this. I wrote this. It's kind of this more of a case study more than anything. It's not really gonna walk you through configuring the entire EIGRP lab. Just really focuses on controlling path using the interface delay. Um, get you a zoomed in outlook of the topology. But essentially, the goal for this is, well, give you a walkthrough of what's going on here. So essentially, you have two multi-access networks, one being a broadcast, one being a non-broadcast. This is a frame relay cloud that connects routers 1, 2, and 3. And then here's an Ethernet segment that connects routers 3, 2, and then switch 1. There's an SBI switch 1 that talks to it on VLAN 237. The master subnet is 155.0, so you'll see the last two of each network listed there, as well as the subnet mask. There's a IPv6 version of this, but in this one we're going to focus on IPv4, only because of the fact that it's essentially, it does kind of operate the same way in respects of controlling path. So, you can apply this to the EIGRP v6 configuration, but the goal for this is going to be router 1. Any routes originated from switch 1 coming to router 2. Router 1 needs to prepare router 2 as the primary path. And then vice versa, switch 1, any routes, essentially we're going to focus on router 4, but any routes coming from router 4 that make it into switch 1, we want to make sure that it's taking router 2 as the primary path. We're really all routes, so we don't want, essentially, it's going to, pre-configuration, it's going to be doing load balancing across the two links. So from router 1's perspective, and I'll show you that in a few seconds here, in a few minutes here when we look at the current configuration before we make the interface delay changes. But essentially, he's going to be, router 1 is load balancing across the neighborship between router 3 and router 2, due to the fact that it's all equal bandwidths on the interface links, as well as all the delay sums as well. So essentially, the router 1 sees any routes coming from from switch 1 as equal from the perspective of router 3 and router 2, so it does equal cost load balancing. And then from the other perspective, same thing. Switch 1, as soon as it receives any routes, especially from router 1 or router 4, it's going to perceive it as equal cost load balancing across router 2 and router 3 as well. And essentially, either way, we want to make sure that the flow of traffic is going through router 2. And the main part, and also a main part of the goal is, in so doing that, we want to make sure that router 3 is still considered the feasible successor in the EIGRP topology table, so that way we can limit queries, the query process on the network, if we do lose the path to router 2. So essentially, we're going to go ahead and take a look at the network here. Alright, so this is the EIGRP, this is the topology. It was actually designed in Visio, and I configured it in GNS3. There we go. I configured it in GNS3. It's actually connected to this server is running an NMS system. It's actually pretty cool. PRTG. I'm pretty sure a lot of people have already heard of it, but I'm playing around with it. And as I do labs, I import the labs and start importing it via SNMP, and it's actually a pretty cool little software. But that's what the cloud is there for. But essentially, this is the topology of what's going on here. So we'll log in to router 1, and as I showed before, we'll go to router switch 1 first. We'll go to router 1. Reverse, doesn't matter. So as I said before, these routes here, the 155.0.7.0/24 is actually coming from router switch 1. And you remember on the diagram, switch 1 is also connected to router 2 and 3. And with the neighbor adjacencies between 2 and 3, we're actually going doing the equal cost load balancing to anything sourcing from router 7. So the loopbacks from router 2 and 3 are going their own respective paths. Honestly, it makes sense to keep it that way, but you can see we're load balancing there. And switch 1, same thing. Essentially, we're load balancing to 2 and 3 to get over to router 1 and router 4. So in this particular lab, the way that we wanted to influence the route path selection was for router 1. The way we did it was we modified the interface sourcing the route. We want to modify that delay to essentially influence router 1 to think that router 2 is the best path. So in this scenario, we modified the Ethernet interface on router 2 to make it be the primary path, where we actually lower the delay value, and by lowering it from router 1's perspective, it's going to look at router 2 as a better metric. Use router 2 in the actual routing table and in the topology table. Because we didn't do such a large variance of the delay from router 3, it should see router 3 as a feasible successor. One of the things to do before actually configuring this is you want to check the default delay values on the interfaces. So on router 2 and router 3, we'll take a look at it there here. Oops, okay. So, show run. We actually don't want to do a show run. You just want to do a show interface, whatever your interface is. In this case, mine is Ethernet 00. And then server's acting pretty crazy right now. Okay, and then we want to include a DLY for delay. Alright, so it's 10,000 microseconds. 1,000, sorry, 1,000 microseconds. So, oh, and then let's take a look at this one here. Man, my server is acting pretty crazy right now, but it's sticking through. Interface. Alright, so you can see that it's the same delay value on both, as well as the bandwidth value. So what I want to do is we want to lower it, and when you're looking at the delay value here, it's in microseconds, so you want to do that times 10 when you're actually doing the configuration on the interface. And I'll show you what I mean when we go into the Ethernet interface now on router 2. Come on now. Alright. 0. So what you do is you just type in delay. And remember what I said, that it's in tens of microseconds, so the delay is showing 1,000 there. That's actually, in this configuration, you're gonna put, it's actually 100. That's the default. So to lower it, to make it 900, you just make it 90, and that should make it 900. So we'll go ahead and do that. And in doing that, it's gonna take a little bit of a second, maybe not. We might already catch the change. That router 1 should see router 2 as the primary path to get to. Okay. Well, and as you see, it's done that there. So router 2 is actually the next hop for the .7 and the 237. As we seen before, it was load balancing. And then one of the things we want to check is the EIGRP topology table. what's happening on the server these days, man. It's kind of acting up, but it is what it is. 7.0/24. We want to make sure that router 3 is actually the feasible successor for this route. And as you can see, slight delay in the variance when you look at the metric. The delay, there's a slight delay there, 26 million trillion, I don't know what that is, the 259. So you can see that router 3 is still the feasible successor. We still have one successor as it's showing there. So so we achieved the goal for having router 1 to see router 2 as the primary path to get to the 7 networks that's sitting at switch 1. Now from the opposite angle, what you want to do now is we want to influence which one to take router 2 to get to router 1 and router 4's networks. And in the lab, the way that I had you guys do it is by influencing off of router 3 for the route sourcing those routes, on the interface sourcing those routes, which is the serial interface here. So essentially what we're going to do is we're just going to bump up the interface delay, and essentially it's going to make switch 1 think that that's a higher metric, because when the dual does its calculation, it's going to recalculate that, and then it's going to use router 2 as the best path. So we're going to go ahead and go back to router 3 and modify its interface. Cool. So switch 1, we'll go back and do a show IP route. Alright, hasn't re-updated yet. Alright, there it goes. So now it's seeing the routes coming from router 1 and 4 as router 2 being the best path, and we'll do a show IP. I don't want to do route, I want to do show IP EIGRP topology 155.0.4.0/24. And same thing here, you'll see that router 3 is the feasible successor, with one successor being router 2 to get to that network, because of the fact that the delay is at a slight variance, as you can see there from the total delay is in the microseconds reading out. So, but that was the quick video explanation of the lab. Feel free to leave any questions, concerns, comments, and happy labbing. Talk to you later.